This example says that a satellite revolves around a planet in an elliptical orbit and its perigee and apogee are 0.5 into 10 to the power 7 meter and 1.5 into 10 to the power 7 meter. And it is also saying that a minimum speed of satellite in orbit is 5 into 10 to the power 3 meters per second. We are required to find the maximum speed in the orbit. Now if we draw the orbital situation, we can see if a satellite is revolving around a planet in an elliptical orbit, we know well that the planet is located at one of the foci, and in this situation, say the perigee is R1 and apogee is R2. We are already given with the values of R1 and R2. And we already discussed that the angular momentum of a satellite which revolves around the planet remains constant during its orbital motion. So when it is at the farthest position, that is at its aphelion point, its speed is minimum. And when it is at the closest position with respect to planets, the speed is maximum. And we can write by conservation of angular momentum. Here we can use Vmax R1, that is the angular momentum of planet at the perihelion point. It must be equals to V minimum R2, that is the angular momentum at aphelion point. Here M gets cancelled out and the maximum speed of planet in orbital motion, which is obviously at this perihelion point, can be given as V min multiplied by R2 by R1. So here we substitute the values. Minimum speed we are already given with 5 into 10 to the power 3 multiplied by R2 by R1. If we substitute the values, it is 1.5 into 10 to the power 7 divided by 0.5 into 10 to the power 7. Here this 10 to the power 7 gets cancelled out, this gets cancelled out, and on solving we are getting it as 1.5 into 10 to the power 4 meters per second, and this will be the answer to this problem, that is the maximum speed of satellite with respect to planet in its orbital motion, and which is at its perihelion point only.